Okay, Assalamualaikum warahmatullahi and a very good day to everybody. So for today class, we are going to have the tutorial. Means that I'm going to give you maybe around three programming for you to look at. And then this is very important because you have to understand how the C++ work on the MicroC. And you can see that how it works on the simulation itself. So for the startup, I'm going to write a very simple code. But before I'm going to write the code in the MicroC, so I'm going to design my board first, which is what I'm going to do. I'm going to design my Proteus first. All right, this is the normal things that you should work on because you have to work with the hardware first. Later, then you come up with the software. So again, you can go to your ICs. All right, so again, just go for PIC16F. So this is the one, and then for the easiest one, we're going to do a blinking LED. So next one will be LED, right? So there's a lots of options over here. You can choose. I prefer to have the bright one, which is the yellow. And then if you have the LED, you should have the resistor. Resistor is this one. Okay, and then you can start. So this is a PIC. Okay, so let's say that we are going to have a blinking LED. So we are going to play at port D here. So LED will be this one. I'm going to have only 4 only. So let's have 4 blinking LED only. 1, 2, 3, 4. And you have the resistor here. 1, 2. Let's try to figure out how to redraw this one. Here. Figure this one first. It's okay. You can use this method anyway. So this one going down first. So you can rotate it clockwise. This is also clockwise. Make it clockwise much easier. And you have to change this one to 1 kilo ohm. Right. So then you are going to have the ground. Of course, our electronics must have a ground. So here will be ground. You can try to concentrate and focus on the area that you want to draw. Okay, now I should have shared all this ground. Should be okay. So okay. Right. What's this? It doesn't want. Okay, so this is all shared. Then you have this one move to here. Much easier for you to look at. This is should be parallel to it. Okay, now you can use port D. I'm going to use port D, right? So this is the one. Here is this one. The second one is this one. And the third one is this one. And the fourth one is this one. This is must be connected. This must be connected. So okay. Okay, so you have LED at port D. Okay, now you can start to write down the codes. So let's put it here. your code here. All right, so let's try to write down very simple. So the process that you know that you have to redo and create your own file again, a project again. So it's very simple. Now you're going to work with port D here as the output. So okay, let's declare it as thrice D is equivalent to 0B. All will be output 1, 2, 3, 4, 5, 6, 7, 8. And the current condition, the initial conditions on the voltage for the port D will be 0. So port D is equivalent to 0B, 2, 3, 4, 5, 6, 7, 8. And then you have the while 1 loop here, while 1. And after this while 1, you must have a bracket, curly bracket like this. You have to have the head and tail, okay, to cover the body. So you can write down inside it. So here you can just put, then what will be happening is this port is going to, port D is equivalent to 0B. So this is the last for RD0, RD1. So it's going to be like this. You can put this 0, 0, 0, 0, 1, 1, 1, 1. And you have to put delay. This is just to delay it, delay ms. This is a function to delay it for 1 second will be this one. Then you turn off back the port D back by using the port D syntax command 0, 0, 0, 0, 0, 0, this one, and you go have to delay again underscore ms 1000. So what you can see that this is the loop that is going to be executed, and you can see that from here this is turn on, delay, turn off, delay, go up again, and this is continuously happening. So let's try to what you call this one. This is try to do this one. Just compile it, project build. So is it a problem or not? You have to check here. Okay, there's no problem. So this is the one. So let's go to this Proteus. So this is 20 megahertz. Do not forget that. So this is where you put your file. Where do I have a file here? It's under here. So it's under here. It's under here. It's under here. So this is the one 854, which is this 855, the latest one. So you can just go okay, and then you can run. You can see that my LED is blinking, right? So this is very simple command: on, off, on, off, on, off, on, off. It's very simple. So you can see that this is actually the one that you have on and off. This is the one that do it once. When your program works, it's going to be starting from here, and then once it's going inside the while one loop, it will never go out. So this is the always the loop that is going to have, they call it infinity loop, something that you cannot go out. Once you go in, it's going to be trapped over here forever. Okay, so this is very simple example. Okay, let's try to improve on your Proteus here. Let's say example that you want to try to have a switch, for port B from port B, and this switch, the function of this switch is to turn on the LED, and if the switch is not on, then it's going to turn off all the LEDs. So you can see that I have these LEDs over here, so I don't want to touch this configuration anymore. So let's try to put one switch at this particular pins at port B. I want to put here. Let's try here, RB2. Okay, let's draw it. So to draw a switch, you must have a power. This is 5-volt switch, right? I think this is the one. So you have the resistors here. You go back to this one, resistors. So this is the one. And then you have to connect RB2 directly to 5-volt. So the input now is always 5-volt if you do not have ground. So you have to put a ground over here. ground before the resistor here. So let me drop down. So here, then you must have a switch here. Okay, let's try to draw a switch here. I always use button, which is a button switch. Cool, let's try here, button. Okay, so okay, when you press this one, when you press this button, the value for input here will be 0 because this is like short circuit. The rules for electrics, right? There will be no current if the resistance is higher compared to this one, because this is no low resistance. There's no resistors here. So once you short circuit this one, this is going to be 0. So what I'm going to do right now is actually, I want to do what? I just want to, if this pin is 0, then the whole LED will be turned on. If I release it, then the whole LED will be off. It's just like your lamp. Alright, so you just want to turn on by using a switch. So this is a configuration, but you can see you have to look here how you want to decide. So your port B now is at port B2 is considered as the input. So you can go back to your Proteus MicroC again. So here you can add and try to define on port B. Tries B is equivalent to 0B 0 0 0 0 0 0 1 0. This is to declare port B at RB2 as input, which is this one. This is RB2, sorry, so it should be here. This should be 0. This is 0 1 2. Okay. The condition you just need to just put port B as 0, because normally for input you do not require to have an initial condition, but this one you have another output there. So you just put everything is 0. 8 of them. So here, okay, you can remove this one and you can remove this one first delay. So there are two conditions here. I just want to say that if I push this one, the LED will be on, which is this one. Okay, so I put here first, going down first. I don't want to mix up this one. So you have to look back at the slides that I taught you guys about if-else statement. So if you want to do if-else, this is related with the switch. So you can try here if bracket, not curly bracket. This is the condition, and this is what is going to do, else, and what is going to do. So you have to remember that this is the command for if-else statement. Okay, so this is condition. This is what is going to do if this condition is met. And what happens if this condition is not met, then it's going to do this one. So this is going to be a infinite loop. It's going to be here like forever. You have to imagine that this is going to be like forever, like very fast and very it's forever and very fast, keep on rotating. So now you have to check this pin, because this pin is the input, right? So you have to check this pin. Is it 5 or 0? So the command will be like this. If port B dot, this is the syntax, dot, you have to look at the pin number 2, RB2, which is they call it F2. This is a pins that you are going to check, which is this RB2. Is equivalent, 2 times equivalent. Okay, this is checking process. If you put only 1, this is wrong, because this is you're going to make it as similar as. So this is not a checking situation. So what you have to do is double equal. If port B dot F2 is equivalent to 0, which is when you switch on this one, then your LED will be on. So you can take this command, put inside here. Else, if this one is not met, this condition is not met, then you're going to have this one, turn off all. So you can put here inside the else bracket here. So what happened now is in this program, this is checking the port B F2, which is this pin. Checking if the port B F2 is equivalent to 0, then port D will turn on the 4 last LED. If this is not met, means that this is not going to be 0. It can be 1, right? It must be 1. So the port D will be going to be turned off, all of them. So let's try. Build here. So is there a problem here? So there's no problem, all blue or blue state here. Okay, let's run this one. Just double check. The latest one is this one, 903, which is the latest timestamp over here. Then you can just run it. You can see now, the input now is 5 volt. The input now is always at 5 volt, means that F2 is equivalent to 1. This is all 5 volt. So let's try to push this button. You can see that? Your LED is turned on. LED is turned on. LED is turned on. LED is turned on. So this is how you're going to configure a switch by using other ports and the outputs at the other ports. So I like to play with the digital I/O normally at port B, at port C and port D. This is our digital I/O. So again, you can just push this button and the LED is turned on. So this is the command that you have. Very simple command. So this is if else statement. This is a switch statement. Okay. So once it's going to be while one is going to be checking all this loop forever. So it means that if I release this one, right? If I release the button, means that the value here is 1. So it means now the port checking is not equivalent to 0 anymore. It's always to 1. So that's why it's going to be turned off all the time. You can see that this because this is turned off all the time. So let's change this one. Let's try to change this one to, instead of 0, I'm going to change to 1. Right? So you can see that what happened right now. Just build again. And then you can run this one. And you can see that all turn on because of the value now is 5 volt. You can see that your command here, checking is it 5 volt? Then if it's 5 volt, then you have to turn on the port D, the last 4 here. If you turn off it, you can see that it's turned off all the LEDs. Right? Quite simple, right? So this is the way how you are going to write a code by using switch, and the if else statements is the command. Okay. So I'm going to have more examples. So let's try to put another switch by using a transistor. So I want to put at port C here. Let's try to put transistor. Just transistor. You just go for bipolar. So NPN. Just put an NPN over here. All right. Okay. Let's try to have a switch by using a resistor. Transistor. This is transistor. Okay. Then you have the LED here. Then you have the ground here. Then you can start to put the connects to the base to the transistor. So you have the power here. This is 5 volt. And this is the LED. Connect to this one. So imagine this one, right? If the transistor, when you learn about the transistor here, this is the base, right? You have to turn on this base by giving a voltage. Then the circuit will connect it from the power to the ground and can turn on this transistor. So what you should do here, is it an input or output? So you have to give a signal out from RC0 to this one. You have to give to this one, right? You have to give to this one. Okay, you have to do this, means that you have to give the value 5 volt from this pin to this pin. So you have to put RC5 as output. So this is RC5. So let's try. Add one more things. So port D, port C. Try C is all equivalent to output. And then the initial value for port C is equivalent to all 0. Okay, let's try to put any of this switch here. So it means that if I turn on here, then this is going to be, let's say I just put here, I just want to put inside here. So this command, okay, inside this bracket, so you can put something else. So for example here, this is port C2 just now. Is it what correct? Is it correct or not? So it's RC5 here. Okay, RC5. Okay, let's try. Port C is equivalent to 0B, 0, 0, 0. This is the one, right? This is going to be turned on. 0, 0, 0, 0. 1, 2, 3, 4. Yeah, this is correct. So you're going to give a signal out from port C pin 5 here. So let's try. Okay, then run this one. So you can see right now is your output is all to 0 because the initial value is 0, right? So let's say what happened when you push this button. You can see that the transistor here at D5 is turned on because you are giving out this signal. You turn on the signals already. This is like a switch already. So you know, because why this is considered all 5, you have to turn off this one. Okay, I forgot to turn off. So what happened here if I have the port BF2 is equivalent to 1, so I'm going to turn off the port C here. You can put here. This is correct. So you're going to turn off the pins and you can see that it's working correctly. Let's try again. This one. So right now I turn on. Your LED now is turned on, right? And then your when you turn off this one, your LED is going to be turned off. This is not really bright, so you can change the values of the resistor maybe to only 100 ohm. Just 100 ohm, much better, I think. Or maybe yeah, 100 ohm. Let's try. Okay, let's try. You can see that the LED is much brighter. Okay, so I turn on this one. You can see that this is given the signal out 5 volt and turn on the base of the transistor, and then the power is going down, turn on the LED over here. So you can see that how my switch is working by using this if else statement. So you can play around a lot of ideas, and the code is quite simple basically, as long as you understand how to work on that. Okay, another thing is I want to teach you guys today is other than binary numbers, right? You also can use by hexa numbers. For example, here, let me go to the let's go to the command here. Okay, for example, here, this is last time. So this is the equivalence of it, of the binary versus the hexa numbers. Decimal is very simple. Decimal is just remove this one. As long as you remove this one, it's considered a decimal number. But what if you are going to change this number to a hexa number here? This is the equivalence on binary to hexa. It's very simple here. You can see that. I always teach my student when you want to convert the numbers, it's very simple. Right here, you just take what color? Sorry. It's much better. So 8, 4, 8 and 4. So 8 hexa. 8 hexa. This is going to be 4 numbers. This is going to be 4 numbers. To binary, 8 is equivalent to 4. This is 1, 2, 4, 8, right? Is this correct? I don't think this is correct. 8, 4. This is 1. This is 2. This is 4. This is 8. Correct, right? Yeah. This is wrong. 8 should be, let me check. Mode base 3 hex. 8 is equivalent to 1000. Yes. So this is wrong. Sorry, this is wrong. This should be 1000. This is 8 and this is 4. This is 4. This is 8. Okay, 4 is equivalent to 0, 1, 0, 0. Okay, so for example here again, in these numbers, right? So let's try to change the thrice V here as a hexa numbers. So you have all 4 0 here and 0 1 0 0, right? So let me what? So what you should do is you have to know that how to put a hexa representation. You must have 0x and the numbers here. This is hexa numbers. 0x, yeah? Alright. So now the example from just now is thrice B is equivalent to 0B, 0, 0, 0, 0, 0, 1, 0, 0. Alright, so you just divide these two sections, and the first one will be 0 and the second one will be 4. Right, this is the one. So the representation will be 0x 04. So you can change this one here. Instead of 0b here, you can change to 0x and 04. It's the same numbers. So can we just try to compile it? So there's no issue. You can see that when you change this one to hexa, the value will be changed to the color will be changed from black to green, but it is the same. Is it correct? So let's try to look at the protease here again. You can run again this one. Yeah, there's no issues. So the representation is correct. So let's try if you want to try to declare. You want to declare all your port C as one, 4 of them is output and another 4 is input. Like for example here, you want to change to thrice D. Thrice D is equivalent to 0B, 0, 1, 1, sorry, 1, 1, and 0, 0, 0, 0. So it's still equivalent to thrice D equivalent to 0x. This is F, and this is 0. Remember that this is the one that we done before. And for decimal will be like this. Thrice P is in this is what 110. Let me check. Let me put here. This 1111 0 0 0 0 is equivalent to 0 0 0. The binary, the hexa will be 240. Thrice D is 240. This is the equivalence by having a binary representation. This is a hexa representation, and the last one is the decimal representation. So you can change this value. So sometimes I will change this one accordingly. If you do not understand this, then you cannot understand what I'm doing right now. So you have to understand how I'm representing the numbers here. All the while, I teach you guys how to use 0B because I want to show you this is which pin is relates to. So for example here, this is related to pin 0, this is pin 1, this is pin 2, this is pin 3, this is pin 4, this is pin 5, this is pin 6, and this is pin 7. So same goes to the switch case over here. You can see that if you play around the switch case here, this is looking at the value here. This is what the value going in. This is a port B. You can see the port B here. So again, today's tutorial is quite simple, but it's very important for you to understand the concept of the programs. I give you three simple concept only, but this concept you should understand up to the next level. Because if you're going to understand this basics programming, then you cannot work. You cannot proceed with the rest of the programming, especially when you start to work on the hardware related to the motors and etc. A lot of input output that you have to remember to understand. Okay, so I think that is part of the tutorial today. The rest will be given in the assessment in ULearn. So once you complete these videos, so do not forget to complete your assessment. All right, I think that's all for today. Before we are going to work on the additional class later, the replacement class, let you guys finish this tutorial first. Okay, see you guys next lecture. Thank you very much.